Hello guys, welcome to these tutorials. In these tutorials, we are going to look at some important Laplace transform properties or theorems. So we're going to be looking at two in these videos. Then we are going to consider another one called convolution in the next video after this one. So first of all, let's look at shifting theorem. Is also known as the first shift theorem. Now, before I dive into this theorem, I want to ask you, or I want to show you something. So, do you know that the cosine graph leads the sine graph by 90 degrees? So, the expression cos theta equal to sine theta plus 90 degrees. The expression tells us that the cosine graph leads the sine graph by 90 degrees. Now, let me tell you something about this terminology, leads. Okay, so in mathematics, leads is always associated with a plus sign. So this is the normal angle, then 90 degrees is your phase angle. So associated with plus for your phase angle, okay, for your phase parameter. So the phase angle will always have a plus sign. So when they say something leads another thing by some particular phase angle, that means you have a plus. Is that okay? So this leads is also known as a left shift. A left shift. Okay. So in another video, I'll dive more deep into this, but I just want you to get the idea. So lead is called a left shift. Now another case is the sine graph, for instance, the sine graph. Okay, so if I want to write another expression for sine theta, I'll say that sine theta is cos theta minus 90. Oh, I hope I'm putting it in the right way. Or cos 90 minus theta, however you want to say it. So cos theta minus 90 degrees. Yes. So what does this mean? It means that the sine graph lags the cosine graph by 90 degrees. Okay, so in mathematics, the term lag is usually associated with a negative sign, as you can see. So associated with a negative sign like this for our phase parameter. And this term lag is called, we call it right shift. So right shift is for lag. Okay, so it's kind of like, it looks confusing. Isn't right shift supposed to have a plus sign, and isn't left shift supposed to have a minus sign? No, it's actually the other way around. So lag is associated with a minus sign and lag is right shift, while lead is associated with a plus sign and lead is left shift. Now let me show you something amazing that will interest your mind about those graphs. So assuming I draw the sine graph, let me prove the first one, that cos theta is equal to sine theta sine what theta plus 90 degrees. That means the cos graph leads the sine graph by 90 degrees. We all know that this is the graph of the sine function. So the sine function is like this. Okay, so you have your sine theta. So this is our pi, and this is our 2 pi, and this is pi over 2 for 90 degrees. Is that okay? So this is the graph of our sine function. So to show us that the cosine graph leads the sine graph by 90 degrees, you need to draw the graph of the cosine function so that you can understand this concept of leading and lagging and this concept of shifts generally. So you have your let me just make it down. So let's draw the cosine graph. So to draw the cosine graph, you will discover that the graph of the cosine function is actually in this way. If you draw the graph of the cosine function, it actually starts like this. Okay. So the same pi over 2 here. Then we have pi. You have 3 pi over 2. Then finally you have 2 pi. Now, where did the cosine graph function start from? If I extend it to this place, you will discover that this is a minus pi over 2. Is that okay? And this is your cos theta. So if you look at cos theta very well and you want to relate it with your sine theta, you can discover that a portion of sine theta can be seen in cos theta. That means this portion of sine theta over here can be seen in cos theta. Can you see it? So it's just as if we moved this sine graph, we moved it to the left by 90 degrees. From here to here is 90 degrees. So they're trying to tell you that if you move the sine graph to the left by 90 degrees, you're going to get the cos graph. I hope you've seen the picture. Just imagine that this stuff was movable. So if I move it to the left by 90 degrees this way, I'm going to get what? My cosine graph. Is that okay? So this is the emphasis of our cosine graph. So your cos theta is a sine theta plus 90 degrees. Now this plus 90 degrees means, just like I explained, it means a lead or a left shift. Okay, so the cos graph leads the sine graph by 90 degrees. It's 90 degrees ahead of the cos graph. So the cos graph is going to reach its maximum point, and it's 0.90 degrees ahead of the sine graph. Is that? I hope you understand that. Now, if you want to see the second statement, that sine theta is equal to cos what? Theta minus 90 degrees. This second statement is that the sine graph lags, okay, the cosine graph by 90 degrees. The sine graph lags the cosine graph by 90 degrees. This one is the cos graph leads the sine graph by 90 degrees. Then the sine graph lags the cos graph by 90 degrees. This is a lag, okay, and it's a right shift. So I'm going to be using another color to indicate this one. So assuming this is your cos graph like this, if you want to get your sine graph from your cos graph, okay, we already know that the cos graph starts from this point normally with respect to our diagram. Cos graph actually starts from minus infinity, okay. I just tried to truncate it over here. Now, if you move this point to the right, if you move it in this direction, you understand, such that this point comes to this place, what you're going to get is this. You get it like this. Is that okay? So this is what you're going to have. So if you move this point, you understand, you're going to have something like this. Let me just complete the diagram so that you see. So moving this point as if it was here, you will now have it like this. So when you move the cos graph to the right, or when you lag, or when you delay the cos graph by 90 degrees, what you get is the sine graph in this way. So I want you to get the picture of what is happening You understand? Especially those of you that might want to do signal processing, you should know all these small tips very, very well. They are very important. So the essence of doing it like this is so that we can see that the cost graph leads the sine graph. The cost graph starts from here, and I want you to know that time starts counting from minus infinity to infinity. So minus infinity is considered as the future, then this is the past. You understand? So minus infinity is considered the future, then infinity is considered as the past. It's kind of like really confusing. That's why in rocket science, if they want to launch a rocket, they'll be calling it T minus 5, T minus 4, T minus 3, T minus 2, T minus 1, and T minus 0. You understand? So when the time starts counting, it will now be T plus 8. When T plus 8 means that the rocket must have been launched 8 hours or 8 minutes ago, but T minus 5 is trying to tell you that the rocket will be launched in the future, which is 5 seconds ahead. So the negative side of the x-axis is usually considered as the future when we are talking about time, while the right side is considered as the past when we are talking about time, something that has happened. Okay, but so the right side is something that has happened, but the left side is something that will happen. So in with respect to cos and sine graph, the cos graph leads the sine graph, or the sine graph lags behind the cos graph by 90 degrees. Now what I just want you to get from this lead and lag stuff is that a lag is usually a minus sign of your phase angle. Why? And it is called right shift. Okay, why is it called right shift? Because when you shift the cos graph to the right, you're going to get the sine graph. Okay, so when you do cos theta minus 90, that means you shift it to the right, you're going to get your sine graph. So I want us to apply what we've learned now from this shift theory to actually what we're about to learn in the Laplace shift theory. Now for Laplace transform, our shift happens by the exponential. Okay, our shifting happens by the exponential. Whether it's a left shift or it's a right shift, it depends on the sign of the argument of the exponential. So let's say you have Laplace transform of exponential 8c multiplied by f of s multiplied by f of t. Sorry. What is this going to give you? The Laplace transform of exponential 8t multiplied by f of t. Okay, according to the shift theorem, it's going to give you f of s minus a. Okay, so this is a right shift, or this is a delay, right? So f of s and f of t form a Laplace transform pair. Now this is how we normally do it. To evaluate the Laplace transform of exponential 8t times f of t, first of all, we'll find the Laplace transform of f of t, which is f of s. Then we are now going to apply the shift by changing s to s minus a in the case where the exponential is positive. But if the exponential is negative, then you're going to have it in this way, f of s plus a. Is that okay? And f of s is still a Laplace transform pair with f of t. So we are going to look at a couple of examples to see how this works. So of course, yes, in this case we have a left shift or a lead. So this is a delay. Okay. Sorry about that. Then I gave you a problem. Find the Laplace transform of exponential 2t sine 3t. So this one is pretty easy. So we already know that the Laplace transform of sine 3t is actually going to give me what? Yes, very good. You have 3 all over s squared plus 3 squared, which is 9. Is that okay? This is the Laplace transform of sine 3t. Now, if you want to apply these shifts now, this is my f of s. If I want to apply these shifts, okay, this plus 2. For plus, you're going to have f of s minus a. And the value of a in this case is actually not 3, but rather this parameter that you have over here. So this 3 is for the angular frequency of your sine graph. Now, the Laplace transform of exponential 2t sine 3t is going to give you, you have 3 all over f of s minus a. Now, simply means that anywhere I see s, I should replace it with s minus a, and a is this value. So you have s minus 2 all squared plus 9. Okay, so this is the answer. Now let's quickly do another one. Let me barricade it. I have the Laplace transform of exponential minus 2t multiplied by, let me say, t squared, for instance. So first of all, find the Laplace transform of t squared. The Laplace transform of t squared, which is my f of s, is going to give me, according to our formula, we have 2 factorial divided by s raised to the power of 3. Remember, the Laplace transform of t raised to the power of n is n factorial by s to the n plus 1. Okay, so remember this theory. So that is what I used to find this one. Now this is my f of s, so I need to apply the theorem. So in this case, the exponent is what? Negative. So I need to use the s plus, that's the lead. Okay, so in this case, my Laplace transform of exponential minus 2t multiplied by t squared is going to be the lead version of this f of s. So an f of s plus a, which in this case, anywhere I see s, I'll replace it with s plus a. I have 2 factorial over s plus a, in this case is 2. Okay, all cube. So this is the Laplace transform for this one. Okay, so another one you might encounter, let's say you want to find the Laplace transform of exponential 3t, then you now have something like cos, hyperbolic cos roots 3t. Is that okay? So let's find the Laplace transform of this one. So we already know that the Laplace transform of cos root 3t, okay, is going to give you what? Very good. You have s all over s squared minus root 3 squared, which is s all over s squared minus 3. So this is for hyperbolic cos. So this is our f of s in this case. So we want to now merge it with this exponential factor. So to see how the shift will apply, exponential 3t and cos root 3t. So what kind of shift are we getting, right or left shift? So definitely this is a right shift, because it's this is going to result in our f of s minus a. When here is positive, you have f of s minus a. This is a delay, and delay is right shift. So this is now going to be, you need to replace s with s minus a. So a is 3 in this case, then you will have s minus 3 all over s minus 3 all squared minus 3. Okay, so everything is gotten from 8c dot f of t gives you f of s minus e, where f of s forms a Laplace transform pair with f of t. Are we together? So this is for shift theory. So let me see if you can pause the video and do this one. Laplace transform of exponential minus 2t, then cos 4t. So what is this one going to be? So pause the video and try to resolve it on your own. So at the end of the day, I want you to comment whether you are having a left shift or a right shift. Yes. So okay, I guess you pause the video, and this is how I would have solved it. First of all, I'll find the Laplace transform of cos 4t, which I know is s all over s squared plus 4 squared, which is a 16. So this is my f of s. So to find my Laplace transform of exponential minus 2t cos 4t, I am going to have it in this way. So because this is a minus 2, okay, then I'll have an f of s plus a rather. So s plus a being that we have our a as 2 in this case, and the plus sign is because of you have a minus here. So remember the theory. So if you apply this, you're going to get, anywhere you see s, replace it with s plus a. You have s plus 2 in this case because your a is 2, and you now have all over s plus 2 squared plus 16. So this is the answer to this particular one. I hope it is understood. I hope you understand. So this is actually a left shift or a lead. Okay, so our normal Laplace transform function, our normal f of s was shifted 2 units to the left. So 2 units to the left is an s plus 2. Okay, 2 units to the left is s plus 2. So please, you need to be very, very careful and conversant with it. So irrespective of that, we already know that the summary is that when we have a Laplace transform of exponential plus or minus at multiplied by our f of t, the summary is that we are going to have an f of what? S, so minus or plus a. So the minus is when your a is positive, and the plus is when your a is negative. So if you have a minus a here, you have s plus a. And if you have a plus a, you have s minus a. Is that okay? So think about this as we move to the next theory in Laplace transforms. So next theory is the theory of differentials or derivatives. So differentials. So this is usually associated with multiplying your f of t by a polynomial. So assuming I have the Laplace transform of a polynomial t raised to the power of n multiplied by f of t, how do I actually solve this? So the proof is minus 1 raised to the power of n, then the nth derivative of your function f of s, okay, with respect to s. So you're going to differentiate your f of s with respect to s n times, and you raise minus 1 to the power of n times. And as usual, f of s forms a Laplace transform pair with f of t, means that the Laplace transform of f of t is f of s, and the inverse Laplace transform of f of s is small letter f of t. Now let me show you an example. So example of how to apply this particular differential theory. If you want to know how to apply this particular differential theory, that's derivative theory, we would solve the Laplace transform of what? Let me show you one example that we did previously so that you understand. So we solved in one of our examples, we solved this, right? And this is the answer we got, right? So I want you to take note of this answer. Let me show you an example with differentiation. So we have exponential minus 2t, and multiplying it by t squared. So example, you want to find the Laplace transform of exponential minus 2t, right? And you want to multiply it by t squared. So in this case, in the case of treating it as the first shift or shift theorem, I used this one as my f of t. Remember, you understand? Then this one was the parameter that contributed to the shifting. But this time around, I'm going to switch the roles of these terms such that my f of t, I'll choose my f of t to be what? Exponential minus 2t. So I want to find the Laplace transform of t squared times exponential minus 2t. Okay? Which corresponds to our Laplace transform of t squared dot exponential dot f of t. So it means that in this case, if I'm using this as my f of t, what I'm going to do is I'm going to differentiate according to the formula above up here. I'll have my answer as minus 1 raised to the power of n, and n is the degree of t here, which is 2, then I'll say the 2f of s all over the s squared. So still this n. So where is this f of s going to come from? F of s will be the Laplace transform of f of t, which in this case is the Laplace transform of exponential minus 2t, which is 1 all over s plus 2. So in other words, I want to find the second derivative of my f of s, which is 1 over s plus 2. I'll find the second derivative and I'll multiply it by minus 1 raised to the power of 2 to now get my final answer. Okay, first of all, let's start with the first derivative of f of s. So according to product rule, quotient rule, when you're differentiating a ratio like this, you're going to have v, which is s plus 2, then du. If I differentiate this one with respect to s, I'll get 0, and minus u, which is 1, then dv. Differentiating this one with respect to s, you're going to have 1 all over v squared. You have s plus 2 all squared. Okay, so u v du, let me just write it. So d of u all over v is actually what? V du minus u dv over v squared. So you should remember this. Let me use the operator format to write it. So v du, then u dv all over v squared. So you have it in this form. If you simplify, 0 times anything is 0, then I'll have minus 1 times 1 is minus 1 all over s plus 2 all squared. So this is the first derivative, dfs ds. So if I differentiate it again, the 2fs ds squared, what are you going to get? So this is my v and this is my u. So as usual, my v will be s plus 2 all squared. That's v du. Differentiating minus 1, you get 0. Then minus u is minus 1. Then dv, I want to differentiate this term. You're differentiating s plus 2 all squared. Just use the shortcut. This 2 comes down. Then you differentiate the brackets. If you differentiate the bracket with respect to s, you get 1. Then you rewrite the brackets and you subtract 1 from the power. 2 minus 1 is 1. So you just leave it like this. And all over the square of this one. When we square this one, what we are going to get is s plus 2 square, meaning square like this, right? So let's find the 2f over the s squared is now going to be, then you now have, in this case, you're going to have 0. This times this is 0, and minus times minus is a plus. So 2 times this is going to give me 2 times 1, and I have s plus 2 all over. This is s plus 2 raised to the power of 4. Okay, 2 times 2, 4, law of indices. Now, if one s plus 2 cancels another s plus 2, I'm going to get 2 times 1 all over what? S plus 2 raised to the power of 3. And this is a 2 factorial over s plus 2 to the power of 3. Okay, so I can now summarize by saying d, that's the Laplace transform of exponential minus exponential t squared, then t squared exponential minus 2t gives me minus 1 raised to the power of 2, then d squared f of s by ds squared, which is minus 1 raised to the power of 2 multiplied by 2 factorial over s plus 2 or 3. So minus 1 squared is going to be 1. Is that okay? So at the end of the day, the Laplace transform of t squared exponential minus 2t is 1 times 2 factorial over s plus 2, 3, which is 2 factorial over s plus 2 to the power of 3. And if you compare this with what we got earlier, you'll discover that it's actually unique. Okay, we got the same thing. So check it out. This was when we applied the shift theorem. Okay, and we got the same answer. Now we are applying the differential theorem and we are getting the same answer. So the summary of this is that whenever you're giving to evaluate the Laplace transform, you're given to evaluate the Laplace transform of a function multiplied by t or a polynomial, you need to apply the differentiation method to find the Laplace transform of those problems. So you find this useful. Okay, this method, some of you might be asking, okay, why didn't we just apply the shift method to this one? If I'm given a problem like this, I see a function and an exponential, I'll usually want to apply the shift method because the shift will give me the answer faster than the differential would give me that same answer. So I just wanted to use this example to show that the formula is actually legit. It's a legit formula, it's true, and the formula works. So you'll find this useful when they give you a problem, like in exam, to find the Laplace transform of something like t sine, or let's say we want to find the Laplace transform of t cos t. Okay, we want to find the Laplace transform of t cos t now. So the truth about it is that you can't apply shift here, you must apply your differential theory. So in this case, my f of t will be cos t, and my f of s, capital letter F of s, will be the Laplace transform of f of t, which is s all over s squared plus 1. Now that I've gotten my f of s, so t has a power of 1 in this case, therefore my Laplace transform of t cos t will be given to me as minus 1 raised to the power of 1, then df of s over ds. So I'm differentiating 1 times because the degree of t multiplying this f of t is 1. So I just need to find the first derivative of my f of s and multiply it by minus 1 to get my final answer. So my f of s is given to me as s over s squared plus 1. So the d by ds of s over s squared plus 1 is going to be, this is my v and this is my u, so I'll write v s squared plus 1, then du, differentiate x, you get 1, then minus u is s, and dv, differentiate it, you're going to get 2s all over s squared plus 1 all squared, like this. Okay, so if you simplify, what are you going to get? You get s squared plus 1 minus 2s squared all over s squared plus 1 all squared. So this is going to give me the 1 minus s squared all over s squared plus 1 all squared. So I've gotten my d by ds of f of s. So my Laplace transform of t multiplied by cos t is minus 1 raised to the power of 1, and d by ds of f of s, which is minus 1 raised to the power of 1 is minus 1, then multiplied by 1 minus s squared all over s squared plus 1 all squared. This gives me s squared minus 1 all over s squared plus 1 all squared. Is that okay? So this is the Laplace transform of t cos t. The Laplace transform of t cos t. So you can try to do this one by yourself, Laplace transform of t sin t, and leave the answer in the comment section. So with this, we have come to the end of 2 major theories that you're going to be using in Laplace transform that you find useful. That's the shift theorem and the exponential theorem. The shift theorem, and the differential theorem. So the shift theorem is when our f of t is multiplied by an exponential function, while the differential is when our f of t is multiplied by a polynomial of degree n. Okay, so you should have your answer in this form, and good luck. So please like this video and subscribe to my channel. In the next video, I'm going to teach you another important Laplace theory, which is the theory of convolution. So it is very necessary that you know how to apply the theory of convolution. I'm going to be showing us the theory of convolution in the next video. So till then, stay blessed. Don't forget to like, share, and subscribe, and I'll see you in the next video. Bye.